Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi everyone, welcome back. So, can someone just please confirm if I am audible and equally visible? So, let me just check if I am audible. Hello. All right, so everything seems good to me. So, first of all, welcome you all to this post analysis of last Biwizard School Coding Contest. So, how was your contest? All right, so let us quickly solve the coding problems and we would not discuss the quizzes. So hoping that the screen is visible to you. All right, so the first problem was the SD problem. So there are n SDs working in a company. The ith SD has E of I years of experience and the CEO wants to select one of them for a lead engineer role, and he want to select the one having the maximum year of experience. So we need to find out how many possibility does the CEO has, right? So the CEO will select the SD with the maximum years of experience, right? And we need to report that how many possibility does the CEO has, right? So from the given list of SD experience, he will select the maximum one, and the number of possibilities will be equal to the number of SDs having that maximum year of experience. So here for the first example, the maximum year of experience is 5 and only one is SD is having that maximum year of experience. So the answer will be 1, right? And in the second example, the maximum number of experience is 2 and 4 SD are having the maximum number of experience. So that's why the answer is 4. So is the problem statement is clear to everyone? Yes, no, anything? Uh, yes, no, anything? Right. So more formally, what we need to do, we need to report the number of maximum element, right? So I don't think these problems require much explanation. So here we have a very simple and strategic implementation. So let me just implement this from scratch. So then just wait for a second. Right, so we need to first find the maximum element of this vector E, which represents the number of experience in years, right? So for that we can use a inbuilt function which is max element, and it will take the beginning of array, that is E dot begin, then iterator to the last, that is E dot end, right? And now it will return the iterator to the maximum element. So that's why we are dereferencing to get that value, and now we need to report that the number of maximum element, that maximum element mx. So initializing the count with 0 and then iterating over this array. So auto I and here I represents the years of experience, then E. So we increment the count, that is C plus equal to I is equal to mx, right? So more formally, it is actually a very simple representation of this statement. So let me just introduce a comment here and then closing comment. Both the lines are both the statements are actually same. Instead of this, you can also write if I is equal to max, then increment count, right? So let's just return this count, which denotes the number of possibilities that the CEO has. So count. All right, accepted. And the time complexity is linear O of n. This inbuilt function takes the linear time. The inbuilt max element function will take the linear time to return the iterator to the maximum element. Then the second problem, which one it is? Yes, the indices problem. So we have an array of n integers, and geek want to know if it is possible to make the sum of integers on the odd indices equal to the sum of integer at the even indices. And in one operation, he can do the following thing. So that is select an subarray and multiply all the elements by -1, right? And he can perform this operation at most once, right? So is the problem statement is clear to everyone? Right. So for the first example, we have an array of 5 elements, that is 1, 5, -2, 3, and -1. So here, after performing the operation on these two elements, so let me just quickly open my notepad. So what we had, okay, so n is equal to 5, and the elements that we have is 1, 5, -2, 3, -1. So 1, 5, -2, or we had 2, let me just check. So -2, 3, -2, 3, and then -1. Then after performing the operation at most 1 on this subarray, then the resultant array will be 1, 5, and multiplying all the elements by -1. So then it will be 2, because -2 multiplied by -1 will be 2. Then -3, and then -1. So the values at odd places, this one plus 2, 3, and -1, which is 2 here, right? So let me just write odd. So 1 plus 2 minus 1 plus -1, which is 2. Then at even position, 5 minus 3. So 5 plus -3, which is 2. So now you can see we can achieve the sum of elements at odd position equal to the sum of element at even position. So hoping that the problem statement is clear to you. And for this example, we return true, which is same as the expected output, right? So now let's see how we can solve this problem. So let me just first write the elements. So a of 0, then a of 1, and I'm using a zero based indexing for explanation. A of 2, a of 3, then so on. A of n minus 2, then a of n minus 1, or more formally I can say a of n minus 2, then a of n minus 1, because of zero based indexing, right? So what we want the sum at odd places equal to the sum at even places, right? Or let me just write uh, a real life examples, that is actual numbers. So a of 4 and then a of 5, considering that we only have a 6 element. So we want the sum at these positions 0 to 4 equal to sum at these positions, sum of elements at even position. Or if we consider one base indexing, so the sum of elements at odd positions, right? So let's say this sum is denoted by x and this sum is denoted by y. So first we find the difference between x and y. So let's say our difference is equal to x minus y, and if this difference is odd, so if, what I mean by this, so if, okay, yes, so if difference is odd, then we cannot achieve the equal sum, right? So in that case we simply return no, that is return false, right? Because we can only distribute the sum into even and odd positions if it is divisible by 2. So if it is odd, then we return false, right? And otherwise, if difference is equal to 0, is 0, then definitely we return true. That is, both the values, all the values are same. That is, both the sum are same. So in that case, we return true, not 0, but we return true. That is, both the sums x and y are equal, right? And now we know, after checking these two conditions, we know difference is even, right? So we need to find difference by 2. Difference by 2. So if I rephrase the problem, then I can say we need to find the subarray with the sum difference by 2. So find subarray with sum difference by 2, right? And once we get this subarray, then we multiply the subarray with minus 1, all the elements with minus 1, that is, we perform one operation. So let's say subarray L to R is having some difference by 2, right? So previously they are contributing a difference by 2. So if I multiply this subarray, so that is, if I multiply all the elements from minus 1, so that is minus 1 will be multiplied with all the elements. So that is a of L plus 1, and so on, a of R, right? So we are removing this difference, and instead of this we are adding a difference, adding minus difference by 2. So what I mean by this, so previously the contribution of this subarray is a difference by 2, right? So, and after performing the operation, so after operation, now the contribution of this subarray is minus difference by 2, right? So the difference between these two, so more formally I can say, oh, the difference between these two is now equal to, so let me just quickly change the color. So difference by 2 minus difference by 2, right? Now we are at okay, now what difference we have changed? So difference by 2 minus difference by 2, so this will be 2 difference by 2. So, and this two get cancel out. So now we got our difference as a difference, right? Diff, right? And that is what we want. We want we want to like subtract this difference, right? So that is x minus y. The sum is having difference diff, and we want to change this difference to 0. We want to change this difference to 0, right? So that only we are checking for a sum of such subarray, such that only so the only thing that we need to check if there exists some such subarray with the sum is equal to difference by 2, and if that is the case, then we return true, and if that is the case, then we simply return true. And this is actually a very standard problem to check that whether some subarray exists with a difference with some sum or not. So how we can solve this problem, that whether we have some such subarray or not? So we can use a map, right? And we can iterate from I is equal to 0 to what we can say n minus 1, and if C denotes current sum, so it will denote current sum. So, or let me just explain you this with an array with, so okay, so a of 0, a of 1, a of 2, a of 3, then some element a of I, then a of n minus 1, right? So let's say we are iterating from left to right, and we are at index I, and C denotes the sum from 0 to I. So that is summation from I is equal to 0 to I, a of I. So instead of I, let's say j, right? So starting, because we have already considered I, so z is equal to 0 till j is equal to I. So a of j. So C will denote the prefix sum from 0 to index I. And now we want to check that whether there exists some such subarray such that there is difference by 2, right? So instead of this by 2, so now we want to check if there exists some such subarray with a difference with some sum, right? So here, from here till here, we know sum is equal to C. So now we want to check if there exists some subarray, some prefix with sum minus C, right? So let's say till here we have the sum is equal to, that is this prefix is having a sum is equal to sum minus C. So what will be the sum of a prefix from, what will be the sum of array from A to A of I? So we know not A of 2 but actually A of 3, right? So what will be the sum? So we know their sum will be equal to C, which denotes the current prefix sum 0 to I minus sum minus C, right? If I was not wrong. Okay. All right. So we need to check if there exists such subarray with this sum, and if that is the case, then the sum from A of 3 to I will be equal to sum. C and C gets cancelled out. Right? So then we simply return true. Now, if I show you the implementation, then here you can go through with this implementation. So first we are finding the difference. So instead of a variable sum, we are having our difference, right? So this variable sum denotes our difference variable. Then we are subtracting the elements which are at even position from the elements which are at odd position, right? So that is finding the difference between x and y. And if it was odd, then we return false. That is, we cannot distribute the odd difference. And if it was 0, then that means both the sum are same, so we return true. Otherwise, we need to find such subarray with the sum equal to sum by 2, or you can say difference by 2, right? So for that we use a map data structure. Then okay, and previously what we did, actually here it was not sum minus c, so we need to check for c minus sum. Sorry, my bad. So we need to check for c minus sum, right? So that the difference from the sum from 3 to I will be minus c minus sum, right? We want to find this sum, right? So we need to subtract this sum from here. So also let me just change the color. So we need to subtract this sum from c. So c minus sum. So when I open this bracket, then it will be c minus c plus sum, right? Which will equal to sum. So and this is what we want, right? We want this sum. And then initializing m with 0. So here we store our data in map, right? Then initializing m of 0 with 1. That is that is considering that we are having some prefix with sum is equal to 0. So then initializing c with 0, and c denotes sum of first I variables 0 to I, a of 0 to I. Then iterating over the values and adding the current element in C, that is updating prefix sum and checking if C minus sum is exist, then we return true. Otherwise, marking M of C with 1. That is, we got some prefix with sum C. And after this for loop, we simply return false. And the time complexity is n log n because of using the map data structure, right? We are using a map data structure, so the time complexity is n log n, or let me just write it over here. So the time complexity is n log n, right? So moving on to the last problem, which was what we had, members of the members problem. So there is a club of n members. They are going to they are planning to go on a trip. Every person decision to go on the trip is independent. That is, will not depend on other person. They can either go to the trip or not. It's depend on their own mindset. And an array ARR is given of n elements, and the ith member says that he wants to go if at least ARR of I other members will go, right? Excluding himself. Or more formally, the ith member will sad if he goes and less than ARR of I other members other than him go, right? Or if he doesn't go and at least ARR of I other members will go. And our task is to find the number of ways so that they can go on the trip and none of them become sad. So let me just explain you this with an example. So what we had, so 5 n is equal to 5, then a rr as 3 0 0, then 3 3, I guess, right? So when the ith member will So ith member, so that is this member will only sad if he will go on a trip, and less than 3 member will go, total number of members on the trip is less than 3. So let me just write the condition. Sad if ith member will go and peoples number of peoples, or we can say members, on trip is less than ARR of I, right? Excluding him. Or if it, or he will sad if ith people will not go, and number of members is greater than or equal to ARR of I. Then he will set, and our task is to report the number of ways such that all the peoples are happy, right? So hope this thing is clear to you. So the very first case, when all the peoples are happy, so in the case when no one will go, right? So if no one will go on a trip, then all the members are happy, because okay, all the members are happy if no one will go on the trip, because in that case the number of members are equal to, okay, so I guess it should be not equal to ARR of I, but should be, okay, it must be equal to ARR of I. If he doesn't go, and at least ARR of I other members go, right? Will not go. And so the very first thing, so case one, when none of the people, no one will go. So in that case, number of people, number of member, I can say, is equal to 0, right? So all the members are happy if their value, so ith member is happy in that case if ARR of I is greater than 0, right? Because if it is equal to 0, so then it means he will not go, and the number of members which are which goes on the party is equal to ARR of I. So this condition is true in that case. If ARR of I is equal to 0, so in that case this condition is true. So the people will that member will sad, right? Because for him the number of members is equal to 0. For him the value of ARR of I is equal to 0. So this condition is true, right? So this will be our first case. And what can be the next case? So the next case, and also one more thing, this definitely gives you an idea that we need to perform some kind of sorting. So if I sort this array, so then what we can get, so then 0 0 3 and 3. So to check the first condition, we check if ARR of I, ARR of 0 is greater than 0, then that means all the elements in its side will definitely greater than 0, because we have sorted in ascending order, right? So if that is the case, then I can say my answer, I can increment answer, or we can say count of a number of ways, right? And then what we can do, we can iterate from left to right, and we need to check for two condition, right? So if ARR of I, and I am considering zero based indexing, is greater than, right? Okay, not actually a greater than, yes, greater than, right? If ARR of I is greater than or equal to I, so for ith index we know I player, we have selected I player to go on the party, right? And if it was less than or equal to I, then it means both the conditions will not satisfy, right? So how many members that are currently going onto the party? So the currently member are going onto the party is I plus 1, right? I previous member, 1 current member. So this condition is true, right? That is excluding the ith member, other I members are going to the party. So, and the next condition that we need to check for, ARR of I plus 1 must be greater than I plus 1, right? Because the current number of players, current number of members that are going to the party is I plus 1. So current number is I plus 1, right? And if for I plus 1th index, if it was equal to I plus 1, right? So then in that case, this condition hold true, right? That is I plus 1, ARR of I plus 1. ARR of I plus 1 is having value greater than or equal to number of members, right? Number of members. So then the I plus 1th person will said, so that this configuration is not valid. So we cannot increment our answer. But if AR of I is greater than I plus 1, then in that case, we simply increment our answer. All right. So, and for a homework, you can dry run the algorithm for the first example. So hope this thing is clear to you. Now let's just try to implement this thing. So here first we sort this array, then checking for case 1, that is if no member will go to the party. So if the minimum value is greater than 0, so in that case no member can go to the party. So we got one configuration, so initializing the answer with 1, then iterating over the indices from 0 to n minus 1, and considering that 0 I person, I plus 1 person will go to the trip, and we need to check if this configuration is valid or not. So for that we check if ARR of I is less than or equal to I, and I plus 1, ARR of I plus 1 is greater than I plus 1. So then it means this configuration is valid. So this OK variable stores true, and we are adding true, that is 1 in our answer. And after this we simply return our answer and trying to submit this. And the time complexity is n log n because of sorting an array, right? So this was all about the today's session, right? So ending this stream over here. Thank you so much guys for joining this session, or let me know if there is any doubt. Right, so yes, ending this stream here.